Hey, Smath here. I got another Dalton's Law of Partial Pressure for you this time, but now we're going to incorporate it with the ideal gas law. So here's what's going on. We collected 193 mils of oxygen gas, O2, over water. So this gas was bubbled up through the water. It got wet. We're going to have to dry that out using Dalton's Law. Now, the pressure we collected this at was 762 millimeters of mercury. The temperature of this was of the water, and it says, and the resulting gas was 23 degrees. So we're going to need that when we plug it into the ideal gas law. This says how many grams of O2. So big picture, we got to find out the pressure. They gave us the water vapor pressure that we need at that temperature. Let me move this over just a little bit for you to get the whole problem in. Sorry. There we go. So we're going to need to get the pressure of the water by drying it out. Then we've got to convert things, get them into good units, solve it using PV/nRT, and then eventually do a mole calculation to find out how many grams. This is a pretty complicated problem, so let's break it down to 3 steps. The first thing we need to do is get the pressure of that gas. What we know is the pressure that it was collected at, 762 millimeters of mercury. Well, that was the atmospheric pressure. That included the pressure of the gas and the pressure of the water. The pressure of the water at 23 degrees is 21 millimeters of mercury. So we've got to fix that. This says pressure of O2. What this really means is this is the pressure of H2O at 23 degrees. So if we take the pressure of the atmosphere minus, this is pressure atmosphere minus pressure gas, pressure water, we're going to get the pressure of the gas. See, what we're really saying is the pressure of the total pressure in the atmosphere, that's the pressure of the gas plus the water. So if we subtract off the water from the atmosphere, we're going to know just the pressure of that gas. So let's keep things moving. 741 millimeters of mercury. Now, guess what? That's that unit of millimeters. We don't have a value of R to use. So we've got to convert that. I converted that to atmospheres. We're going to use 1 atmosphere is 760 millimeters of mercury. So we've got 0.975 atmospheres. Now, that gives me my pressure. Now let's pull this in. That was the first part of the problem, get the pressure of the gas. Now we got to do a PV equals nRT. We're going to work that in. We know the pressure of this gas. We just calculated it, 0.975 atmospheres. What's the volume of this gas? 193 mils. Be careful, 0.193 liters. You got to convert that into liters to use an ideal gas law because we're going to solve this for moles, and this value of R is 0.82 liter atmospheres per mole Kelvin. That's why my volume has to be in liters. That's why my temperature coming up here is going to be in kelvins. The temperature was 23 degrees. 23 plus 273 is 295 Kelvin. So if I take that, sorry, that's 296. If I take that, solve this for N, I'm going to end up getting the moles of oxygen gas. And in this case, it's a pretty small number, 769, 10 to the negative 4th moles of O2. That's the second part of the problem. The third part, we're finally going to get to an answer. Bear with me here. We want to know how many grams. Last thing we've got to do here is say that 1 mole is 32 grams because that's oxygen. I'm just getting that off my periodic table over there. And what we're going to find out is we have 0.0246 grams of O2. I'm pretty sure if I look, I've got 3 sig figs almost everywhere. So my answer is going to have 3 sig figs right here. That's a Dalton's law, collecting a gas over water and putting it into the ideal gas law. A little bit complicated, got a few steps. With some practice, I'm sure you can get this. I'm Smath. I hope this video helped you.